Hi guys, my name is Peter. Welcome back to Tech Savara, and today we want to talk about our video game technical design document. But before I get into that, I have some good news about my previous video, which was about the SwiftUI navigation control system. So you might know that I did the video about the problems relating to navigation on SwiftUI. So my kind of beef, my problem was with the fact that after all these years, we still can't get navigation working properly. So 3 days after I released that video and I put it up on LinkedIn and a few other places, the views went up, and all of a sudden I get a message from Feedback Assistant, which is Apple's bug reporting tool, and they said that they're looking into the issue. And then a few days after that, they said they asked me to check out the iOS 17.1 beta, and lo and behold, it was fixed. So that's great news. Apple have fixed that issue, and that will be released in iOS 17.1, which is good. We've already done a lot of work on iOS 16 to support that, and 17, so it works on both with minimal side effects on 17.0. So we've covered our bases there, but it's good to know that moving forward, that issue is going to be fixed. All right, so with that out of the way, let's get straight into working on our tech design document. Let's do it. So, technical design documents, system architecture documents for video games. The thing with these documents is that they're designed primarily for the technology team in a video game to plan the work that's required for building the technical aspects or the system aspects of the game. So we have our game design document, which I mentioned, and that contains kind of the gameplay elements that sit, they're the core of the game that defines what actually happens. And the technical system architecture document defines kind of on how it's done, how it's built, how it's going to work on a computer, on a console, on the device. It talks about the implementation details of how we're going to draw everything, how we're going to play audio, how we're going to do the systems that put the game together. And really that's what this is. I've got a basic structure that I've done, and the next step will be to actually fill out the details and start explaining and developing the idea of how we're going to build it. Then once this document is kind of complete, we have a starting point. I mean, it's not the be all and end all. You don't want to use it like we have to get everything right in this document before we start. The idea is that it gives you some kind of guidance on what you need to do for each system, right? So, and how it's going to work. So it just helps you do these things before you get into coding and realize I'm doing it the wrong way, or you kind of give yourself the opportunity to think about it at a higher level and not get straight into code. So speaking of getting straight into code, let's get straight into writing this document, and we're going to talk about each heading, each title of this document, and walk through some of the things that we're going to write while we're building it. So we're not going to go through the whole thing. We're going to go through just a summary so I can mention some of the most important things you want to put in this document. All right, let's get into writing. Here we are with our tech design document. Very simple layout. We just have the title here, and we have our aim. I like to call it the audience introduction and meaning. And what it just tells us is like who the document is for. It's for the technical team, and what is it meant to do, this document. And it defines the core systems and the summary implementation for our first game. So just a summary of what is the purpose of this document. Each document will provide a high level and what it does, right? The purpose and what's in it at a high level, and what we want to achieve by the end of it. So it's kind of like we want to write this to drive the initial, the purpose why we want to create this document. And generally, once we start after that, we know what we want to do here. And the requirements are like the system requirements, right? So it's not just requirements, like the system requirements of what we want to support. So the system will run on Apple devices, primarily aimed at Mac and iPad. We'll need a touch interface and a point and click system. So generally the input, which is a separate item here, will tell us more about this. But we want to be able to support point and click system and a touch interface system. At a high level of the next step is like to define the high level architecture, and this will tell us the gameplay. In here, we would have like say this, scripting system, right? And the scripting system, what will the scripting system? We have the scripting system. We would have, the gameplay would have the state machine. Right, the state machine will basically tell us, what state each player is. We want a state machine system at a high level to define, like, whether a player is doing something, whether they're walking, whether they're running. It helps us define states, like switching between states. We also want a high level structure, right? So we want a game state, and game state is basically telling us the state of the entire game world at the high level. So it's not like, it doesn't tell us anything about the details of how the things are implemented, but it tells us, like, so this is if we were to take the game design, this area, this part of the code is the closest part of the game design. It should be a kind of a reflection of the game design. And entities, people call it ECS, entity component systems. We want to define, like, the entity component systems that we want to use. We want to talk about, entity component systems. We would have assets, right? Or render graphics, entities, graphics component, right? We would have a audio component in the entity. And audio objects that play certain things. So these are like the definitions that are platform agnostic in a way. So we have this that implements the gameplay, and it runs on this entity system. So the objects in the world, right? The reason for that is when the systems operate, we want them to run on a list of entities for optimization's sake. So we have 100 gameplay objects, right, that are in the game, right? So we have like basic gameplay game object. It's the high level thing, like, or 1,000, right? And each of them has a graphic, or for half of them have graphics, right? So we've got 500 graphics objects, and we want to pass all those graphics objects and update them in one loop. So the system will take graphics objects for graphic rendering. So we'd have the renderer, and we'd have the audio player, right? Audio player, and then we'd have the system update. We'd have say collision updates. So if an object has a collision object in an entity has a collision object, then the collision system will take all of the collision objects and resolve the collisions, right? And it would pass create events that would then exist within these entities, and the entities would pick up on these events. They'd either do it based on the resolution of the collision and the state machine here, or the game state and the scripting would pick up an event, right? So gameplay, we want an event system, right? So we want to communicate between the different gameplay components. So how that's all going to work, we're going to kind of look into it. It takes some time to figure it out. The idea is to be able to create a world where the game can exist in the vision of the game design. So as you can see, we've got like the first start of the document going. So I'm going to continue writing this. I'm not going to go through all the details, but essentially we'll have the input. So we want to define how we're going to handle our input. Graphics rendering. So we're going to do. We know we want to use metal, right? Metal underlying metal. Blitter. We'll call it blitter, or maybe that blitter is not right. Like a graphics 3D triangle rendering of 2D sprites, right? So we're going to have 2D sprites, and we want to render them using the metal 3D, so we can do all kinds of cool effects. We have an effect system. So these kind of things all kind of feed down. We then have the audio. We'd have the local persistence. So local storage in Mac platforms runs using simple file storage. So local storage will be only like a single file. But then what we want to do is we have it only as a backup, right? So we want to do it in the event the player's not connected to the internet. So say if you're out of internet access but you still want to play your game, you'll always have access to your local file storage if you've downloaded it from, say if you've got a new phone and you haven't logged into your account yet, you won't have it, right? So you do need the internet to get into that initial state, or to update it if you have a previous state. So things like local storage, we'll have to work out how that works. You know, if you go to if you've got 2 sessions open, how's that going to work? What if the date on one is not updated, so you play on one game but doesn't update to your API, and then you open one on another phone, another game session? How is that going to happen? Is this the right way? So you kind of start thinking about these things, you start writing them out, and you go, well, actually that's not going to work, so we'll have to do it in a different way. So online persistence, this will talk about our entity component system. So how will the EC entities, how will all this entity component system work? Our state machine, our asset management for files, audio, graphics, how the gameplay loop will work, and the game code scripting system. So what language we're going to do it. We're going to do it in Lua, Python. We're going to do it in just our general Swift code. So that's the tech design document in a nutshell. And I'm going to keep working on this over the weekend, and hopefully have some more detail to talk about regarding this when we get back to it in a couple of weeks. So guys, I will catch you in the next video. Thank you, and I hope you gained some insight from this video about how to start the process of building a video game. Right, catch ya. Bye.